Alright, so today we're going to talk about myopia. So let's say that here's your eye, and this is the lens in front of your eye, and here's the retina. So a normal person, when they look, the light comes in like this, and then all the light will then be refracted into one spot right here on the retina, and that way you can see. What happens when someone has vision problems is either the light is converging too early, like this, right? It's not reaching the retina, or the light is reaching too late. So like it's not reaching the retina at one point. So those are the two problems. And to fix the problems, we need a lens, right? So let's say we put a lens in front of this man's eye. What happens is the light comes in, right? And then the light either bends inward or and then everything could hit the retina at one point, or it could bend outward so that it helps all the light converge at one point at the back of the eye. Now we could do some math too. So actually, let's define some terms. So this is an equation. So F is focal length. DI is the length from your far point to your lens. We'll define far point later. And then DO is the distance the object you're trying to look at is. So let's say in a real situation, the lens of your glasses is about 1 centimeter or 0.01 meters away from your face. And you're looking out. And say the furthest you could look out without everything being blurry, so without the lens, right? If you're looking out here, say this is this length right here, not including your glasses, obviously, is 5 meters. Then we could say the furthest you could see without your glasses is 5.01 meters, right? And that's what you call your far point. And then let's erase this and then redraw the lens. So everything past the far point is blurry. You don't really see anything very well. So that's not ideal, right? So to calculate how strong this lens needs to be in order to get all the light to converge at the back of your eye, we use this equation right here. So the distance of this 5 is actually going to be called DI, and then here's the object you're trying to look at, a distance of D naught away from the eye, so that distance. Now, because let's just assume the object you're trying to look at is very far away at infinity. Then you plug it into this equation right here, and 1 over infinity is equal to 0. So this means that we can actually cancel out this right here. And the new equation is just 1 over f is equal to 1 over di, right? So now let's try to find out what f is equal to. So you could plug in the 5 for di right here, right? So 1 over f is equal to 1 over 5. And then f will be equal to 5 meters. So now that we find f, it's a good start. It's the focal length. We want to find it in terms of what actually is used when you look at glasses, which is the refractive power. So the refractive power is actually just 1 over f. So 1 over f is equal to the refractive power, and the unit is diopters. So diopters, right? And in this case, 1 over f is equal to 1 over 5, which is actually 0.2. And now what's actually really interesting is when you're looking at your prescription, you always see a negative sign. So that's because when you're solving this equation, f will always be negative. So f is actually negative 5. That's your focal length. And that's because if we look at like the eyeball as an x-y axis, this is the x, right? And this is the y. Or sorry, this is the y, this is the x. This direction is negative. And that's why everything is negative. So now we can erase everything and redraw it a little bit more clearly. So here's your eye, here's your retina, here's your lens, here's your far point, 5 meters away. This is 0.01 meters. And then this is object, right? If this was the case, the doctor would tell you, right, and then this is obviously 1 over -5, well, to tell you to get a lens with refractive power of 0.2, -0.2 diopters. Now, the unit or the change that really matters is your far point. So let's say your eyes are a little bit better than mine, and you could look and see 10 meters, right? So 10 meters. Now the math comes out a little bit different, right? Because 1 over di is equal to 1 over f. And so the focal length is now -10 meters. And then the refractive power is going to be 1 over -10, which is -0.1 diopters. So if you have vision problems, obviously, this is the way to solve for how strong of a lens you need. Whether you have myopia or hyperopia, like, doesn't really matter. That's how you calculate it. So yeah, cool.